All right, boys and girls, we're looking at activity sheet 3, not enough numbers. If you watch this is going to be taped in 2020. So some of this stuff is a little bit dated because it's based usually around 2010. I think this is when this initially came out. So we're going to talk about telephone numbers. We're also talking about license plates and things like that, but mainly to begin with, telephone numbers. Obviously, when you start dealing with these things, we're dealing with the counting principle. The counting principle basically tells you how many of something you can have. So I don't know how many times you guys have had passwords in the past or now, but the reason why they make all these restrictions on passwords now, like you have to use a number, you have to use a capital letter, you have to use a little special symbol and things like that. What that purpose of that, while it's very frustrating at times, the purpose of it is so that it creates more possible passwords, if you will. So that's kind of where we're at right now. We're going to be talking about area codes, the exchange code, and what's called the station code. When I was a kid, when I'm growing up, this was my home phone number. We didn't have cell phones, by the way. I was born way before cell phones. So this would be considered my exchange. It was 292, and this was 1365. Now, about mid-80s, somewhere in that frame, all of a sudden they said, hey, dude, if you want to reach this person, now you got to dial the area code first, okay? Which is my area code, which is here. The problem with that is I remember being a kid going, why I have to dial the area code now? What's the point of that? Well, the point of that is by creating more area codes, you create more possible phone numbers. So for instance, you could have this number is 404-292-1365, and then you could also have it as 770-292-1365. So basically by creating that area code, it doubled the chances of having that number. And obviously it's going to do a little bit different than that. It's more than just doubling. And we'll start talking about that more as we get deeper into this type of material. However, this is just kind of like a very simplistic understanding of why area codes. Then obviously you had 678. You could go there. I never dialed any of these. I just knew that this was mine. And then I think there's 470 now and all these different things. All that does is allow for more phone numbers. I'm not going to read all this out, but basically we're talking about the North American Numbering Plan Administration. This administration basically determines a lot of things to make sure that we have enough numbers. Cell phones are all over the place now where they weren't 20 years ago. You know, we talking about pagers. No one probably has a pager these days. And fax machines obviously are still in place, so they need a number, but not to the degree that they once were. The big thing is obviously cell phones, and they're everywhere now. Little kids have them. So we need more numbers. All right, so that's kind of where we're at. We're going to use the counting principle to determine some things. There's a lot of words that go involved with this type of stuff. Please just stay with me. All right, so we have the area code, and that's going to be kind of labeled as NYZ. In mathematics, you'll know that there rarely exist any more numbers. A lot of things are just letters at that point because they're all variables. They can all be changed. The exchange code is going to be ABC, and the station code will be XXXX. And we're going to try to stay somewhat consistent with that kind of coding when we start asking you questions. All right, so if we look at this first example right here, it says before 1995, all area codes had the form NYZ. So really all we're going to be worried about today is the area code for number 1. We're looking at how many area codes. We're only looking at the area codes. So before 1995, how many area codes were there? Basically is what we're looking at. So area codes had the form of NYZ, where N was any digit 2 through 9. So n could equal 2, 3, 4, 5, 6, 7, 8, or 9. That's a total of 1, 2, 3, 4, 5, 6, 7, 8. That could be 8 different numbers. Okay? Crucial understanding. Y was 0 or 2, 0 or 1. 0 or 1. It was 2 different numbers. And Z was 1 through 9 if Y was 0. So if Y was 0, Z equals 1 through 9. Okay? Which is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits. And if Z, or I should say, Z was 2 through 9 if Y was 1. Two, 3, 4, 5, 6, 7, 8, 9. 8 digits. And basically what that eliminated was so the restrictions on N saved 0 for call operators and 1 for long distance. So N couldn't be 0 or 1 based on calling operators and or long distance. You don't really dial 1 anymore for long distance. You just dial the area code. But in the past, you used to dial 1 and that determined that it was long distance. And these little restrictions that are here with if Y is 0, then Z could be this. If Y is 1, then Z could be that. This determines based on the OR. So you're going to have to build 2 different cases, if you will. Okay, when I say 2 different cases, I don't know if you remember back in geometry when you were doing probability, the OR basically said, OR meant to tell you to add. Okay? You got to add them. Okay? It was this or that, and you had to add them. So a lot of this stuff we're going to do, you're going to have to kind of decipher all of these words. You will see problems like this. So you're going to have to read through, kind of pull it apart, kind of like I did, and go from there. Some of them are not always going to be so straightforward. Okay, so we need to determine how many area codes. Well, we have 2 separate examples. The first example is if my Y equals 0. If my Y equals 0, then I have this. If my Y equals 1, then I'm going to have something totally different. So if my Y is 0, we're going to label these out appropriately like this. If my Y is 0 here, then this is Y equal to 0, and this is just one number. If my Y on this side is equal to 1, it's still one number. If my N could be 2 through 9, that's 8 different numbers. If my N doesn't change, 2 through 9, still 8 different numbers. What changes is when my Y equals 0, my Z equals 1 through 9, or is 9 digits. And if my Y is 1, then my Z equals 2 through 9, or is 8 digits. When we get this type of stuff, we're dealing with the counting principle. You multiply all of these. I don't want pens that don't work. Trash. You multiply all of these. But the OR dictates addition here. So 8 times 1 is 8, times 9 is 72, plus 8 times 1 is 8, times 8 is 64. 72 plus 64 is 136 different area codes possible. Now, while that's not the hardest thing we've ever done, this is the breakdown of how you would do it. You would have to go in and pull all of this different information apart. You must be able to filter info. You must be able to filter it and pull it apart and determine what the actual question is. Okay? That's how that one's done. This is your final answer. So let's get to the next problem. Restrictions that y equals 0 or 1 were removed. Let me move that. Were removed in 1995 because possible area codes had been assigned. Today, n is 2 through 9, y is 0 through 8, z is 0 through 9. The exception to these rules are codes for the forms 37Z and 96Z, which are being reserved for future use. Area codes where y equals z are called easily recognizable codes and are often assigned to special services such as 800 or 877, where we have NYZ, where y and z are the same number. Okay? According to post-1995 rules, how many area codes are possible today? So how to do that, how you would do that is you need to determine which ones are which. So we're going to say n equals 2 through 9. So that's 2, 3, 4, 5, 6, 7, 8, 9, 8 digits. Y equals 0 through 8. 0. 1, 2, 3, 4, 5, 6, 7, 8. That's 9 digits. Z, 0 through 9. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits. Total. So those are our breakdown of our digits. So to determine what our total numbers would be, right, would simply be n, y, z, n is 8, y is 9, z is 10. 8 times 9 is 72 times 10 would be 720 possible area codes. However, if we go back, we have some restrictions. What are those restrictions? So these are total possible. However, there's a few that we cannot use. So we need to take those out, if you will. We need to take those out. These exceptions are right here, which means that our n, y, z, okay? So what that says is when this number here is 3 and this number here is 7, what is our z? So how many numbers is 3? 1. How many numbers is 7? 1. How many numbers is z? 10. So that's 1 times 1 times 10 is 10. The next exemption is 9, 6, Z. How many numbers is 9? 1. How many numbers is 6? 1. How many numbers is Z? 10. That's 10. So we have 20 exemptions, or exceptions, I should say. 20 exceptions to the rule. So when we have 720 possible, 20 of them cannot be possible. 720 minus 20 equals 700 total possible. And that's the first recording. I'm going to do this in a two-part thing just to split things up. That's the first one. Good luck. We'll talk soon.